Welcome back to RoboCNC. I'm Marcel. For those of you following along, you know that we have quite a lot of CNC machines and we're building even new ones as we speak. This one is, for instance, the CO2 laser, and a CO2 laser can do 2D cutting and engraving. For instance, if you want to do a foam inlay. But what if the shape that you need to inlay is quite complex? How do we copy that geometry? This is my small CNC mill and I use it for metal work and brass and aluminum stuff. For instance, for emblems. Like if somebody asks me to replicate this emblem or even make a bigger version of it. How do I copy this geometry without spending hours on CAD? This is the CNC router. We built it here on the YouTube channel and we can use it to create complex geometry, 3D geometry. But what if someone delivers 3D geometry like this and we want to engrave on this curved surface, for instance? So what if you're working on a completely new CNC machine for the YouTube channel and you need to do measurements on the framing? For years 3D scanning and metrology was only found in high-end inspection labs, but today it's finding its way into workshops like mine. Meet the Revopoint MetroY Ultra CMM Edition, a metrology-grade 3D scanner built for reverse engineering, dimensional inspections and precision measurements. Now before we dive into the specification or even using the scanner, let's first take a closer look at the hardware itself, because once we understand how the optical system works, those numbers start to make a lot more sense. Let's start at the back of the scanner. At the bottom you will find a locking USB-C connection carrying both power and data through a single cable. And on the top you will find the controls for operating the scanner. You can start and pause the scanning, change the depth exposure or even cycle between the different scanning modes without having to go to the computer. The real engineering, however, is all on the front. Here we can see 8 different lenses and 12 LEDs. All these optical components have their own dedicated function and together they do 5 different scanning modes. Based on my research, the camera at the very top appears to be functioning as the primary depth camera, effectively acting as the scanner's dominant eye. It's also the camera that provides the live view inside the scanning software, allowing you to position the scanner and monitor the exposure in real time. On the opposite side is the second depth scanner, and together these cameras observe the object from a slightly different viewing angle, much like your own eyes. By comparing the differences between those two images, the scanner uses optical triangulation to calculate the precise X, Y and Z coordinate of millions of measurement points, creating what is known as a point cloud. Surrounding each depth camera are 6 blue illumination LEDs. Their intensity is linked to the depth exposure setting inside the software, providing controlled illumination. This helps the optical system to capture different materials and surface finishes. Moving down, we first find the RGB camera. And while the depth cameras stay responsible for geometry, this RGB camera can capture color information whenever color scanning is enabled. Below the RGB camera we find 4 dedicated optical laser projectors. Each projector is responsible for a different scanning mode, allowing the MetroY to optimize its measurement strategy for a wide range of applications. The top projector generates a single line scanning mode. By projecting a single blue laser line, it can capture deep cavities, narrow slots and recessed features that would otherwise be difficult to scan. Directly below that are the crossline projectors. These two lenses project 34 intersecting crosslines, providing ultra-fast scanning and making it the preferred choice for many of the general purpose scanning tasks. The lower laser projector is responsible for the parallel line scanning laser mode, and its denser 15-line laser pattern is optimized for capturing finer details on surfaces whenever maximum resolution is required. Finally, at the bottom is the full field structured light projector, which projects 62-line blue full field structured light pattern across the object, allowing for a rapid marker-free acquisition of a feature-rich object. You'll notice that every one of these projectors uses blue light, and that's no coincidence. Blue light has a very short wavelength of approximately 450 nanometers, which results in the ability to scan much finer detailed features, improve edge definition, but has also a higher measurement accuracy and is less sensitive to interference from ambient lighting and reflective materials, which makes it particularly well suited for precision metrology. Talking about precision, every piece of measurement equipment needs to be calibrated first. The MetroY Outtro is no exception. A precision glass plate containing reference targets at known locations. Glass is used because it's extremely stable and it can be manufactured to micron level accuracy. Simply click the calibration button, follow the on-screen instructions, and within a few minutes you're ready to start scanning. So enough theory, let's put the MetroY to work. I got this machined aluminum part and the goal is to reverse engineer it in CAD while verifying some critical dimensions. And since we're aiming for the highest possible accuracy, I'll be using the 3 laser modes during this scan. To allow the software to align those scans accurately, I'm placing tracking markers around the part that I'm scanning. Some are positioned directly on the table, while others are mounted on these small 3D printed marker stands that give the scanner additional reference points from different viewing angles. I will also raise the part slightly off the table. That makes it easier to separate the part from the background during post-processing. Although the MetroY performs surprisingly well on reflective metal surfaces, I still prefer to use a thin layer of scanning spray. The spray creates a uniform matte finish, reducing reflections and allowing the blue laser lines to be captured more consistently. The result is a cleaner scan with less noise and more reliable measurements. Now, I'm not going to turn this into a full software tutorial. Instead, I will give you a quick overview on the workflow while we scan this part. I'll start with the 34 cross-line mode. It's the fastest laser mode and ideal for capturing the overall geometry. In this mode, the MetroY scans up to 90 frames per second, capturing over 3 million points every second. Once the overall geometry has been captured, I switch over to the 15-line parallel mode. This mode has a denser laser pattern, making it better suited for capturing the finer details and sharp machined edges and steep walls. Finally, I switch to the single line mode. It has the lowest speed of acquisition, but it's excellent for reaching into deep cavities, narrow slots and these small drilled holes that are difficult to capture with the wider laser pattern. With the scan complete, there's just a little post-processing left. I'll remove all the unnecessary scan data, convert the point cloud into a mesh, and since I only scanned one side, I'll close off the entire back face to create a watertight model. Earlier I mentioned I wanted to reverse engineer this part and perform some critical measurements. But before trusting any of those measurements, I'd like to verify that the scanner itself is actually performing as expected. And that's where the included metrology grade ball plate comes in. Each sphere has been calibrated and the exact center-to-center distance is supplied with the scanner. By scanning the ball plate and comparing the measured values against those certified dimensions, I can verify the scanner's measurement performance right here in the workshop or on site. And the process itself is almost entirely automatic. Simply scan the ball plate and the software identifies the spheres, performing the measurement and comparing them against the certified reference value. The software reports a deviation of just 11 microns, and that's about 1/6 the thickness of a human hair, because apparently every precision measurement instrument needs to be compared to a human hair. More importantly, it's well below the scanner's specified single frame accuracy of 15 microns, confirming that the scanner is performing within specification and giving me confidence that the measurement I'll be making on my part can be trusted. So now that we've verified that the scanner is performing within specifications, we could finally answer the question, can we reverse engineer this part? And the answer is yes. However, this particular component isn't mine. It's owned by Thomson Aerospace Seating, and this is part of an aircraft seat, so I won't be recreating the geometry and sharing the CAD model. If this were, however, my own part, this is where Revo Measure comes into play. So now I haven't worked with this software, just trying it out myself, so I will do a more in-depth video later on. But the beautiful thing would be that you can import a CAD model and then do all kinds of comparisons with the scan data. So if you modeled something in CAD, you machine it on your CNC machine, you can confirm that every measurement is as it should be. For now, just let's do some basic measurements. Let me create like a plane on this side. Let me make a plane on this side. One on the top. And let's compare some angles, for instance. So what is the angle of this plane compared to this one here? Measure. And we can see that the angle between those two planes is like 7 degrees. You can do radiuses, you can do parallelism. These are all kinds of tools. To be precise, this is the GD&T, which stands for geometric dimensioning and tolerancing. So you can specify tolerances and check if they are within your specs. And then afterwards you can, for instance, create a full report on your tool. Now, let me do a quick check on the ball plate. So this was the ball plate scan that was all automatic, of course. Let me create some spheres. So it created a sphere. Let me create this one. Create. And let's measure the distance between sphere 1 and sphere 2. Do measurement, and we can see that it is 96.97 millimeters. Well, it is within the 10 microns. So enough with all the CMM and the high accuracy and the high precision measurements with blue lasers and stuff. Some things can be scanned with full field mode. And full field mode is a scanning mode that is used with a feature-rich object, and you do not have to use the scanning markers. And this is the RoboCNC Workshop, and this, that's difficult, is a vent hole of the RoboCNC Workshop, and this vent hole has a lot of features, like the cement that is breaking down. It is a repetitive pattern, which is not ideal for full field scanning, but I think there are enough of these breaking cement stuff, so hopefully I can scan this window to make a vent hole for my plasma build. And if you are not subscribed, it's time to do so. We are building a new CNC machine and you got to subscribe to watch that. For this scan I'm going to use the optional mobile kit, which is included in the MetroY Ultra CMM edition. The mobile kit powers the scanner with a built-in battery while maintaining a wireless connection to the computer, so no USB cable running from the scanner to my laptop. Using the Revopoint Mirror app on my phone, I can now monitor the scan in real time without having to walk back to the computer at every pass. This wireless workflow is a little slower than scanning over USB, but at applications like this it's the worthwhile trade-off. Instead of dragging the computer and the cable around, I can just simply focus on the scan itself. Unlike the laser modes we've seen so far, the full field mode doesn't project an individual laser line. Instead, it projects a structured blue light pattern over the entire scene, allowing the scanner to capture a much larger area in each frame. Because the scanner is continuously capturing the geometry and visual features of the object, it can track its position without the need of adhesive markers, provided that the object has enough unique surface detail. In this mode, the scanner can capture up to 7 million points per second, making it ideal for larger objects where speed is more important than achieving the highest possible accuracy. And in the end, it seems it created the model that I need. So far we've been using the handheld scanner. 3 different laser modes and the full field mode for the bigger feature-rich objects. Now for smaller objects, Revopoint has an automatic turntable and a small tripod to create a compact desktop scanning setup. The turntable connects to the software over Bluetooth, so the entire scanning sequence can be automatically controlled. You can use the turntable with every scanning mode to just let it rotate and scan the part manually, but you can also switch it to automatic mode and let the software take control. For CNC work, geometry is usually all that matters. But when appearances matter too, the integrated RGB camera can capture the original colors, creating a fully textured 3D model. And that brings us to the end of the first look of the MetroY Ultra CMM edition. I want to thank Revopoint for sending me the scanner to review. They provided the hardware but haven't had any influence on what I had to say or show in the video. As always, this is my own experience and my own opinion. But this will definitely not be the last you'll see of the MetroY on this channel. I'll be putting it to work in upcoming CNC machine build projects where we'll find out how useful it really is. If you enjoyed the video, don't forget to drop a like and subscribe if you haven't already. And if you have any questions or ideas for future scans, let me know down in the comment section. Thanks for watching and I will see you in the next one.